Okay, so this is my first video on probability distributions, and I'm going to look at my first distribution, which is the binomial distribution. Now, there are four conditions to the binomial distribution, and you need to make sure that you learn these because they will not appear on the formula sheet anyway, and they could ask you to justify a distribution or to list these. So the first one is that there can only be two outcomes. There's a success and there's a failure. And that has to be repeatable because there are a set number of trials. There's a set number of things that get repeated. And each one of those trials has to be independent of each other. So getting the last result cannot affect getting the next result. And the last probability is the probability must be fixed. Okay, so it can't change per trial. So those are my conditions for the binomial distribution. And now let's introduce the actual formula. Now this formula is where N is the number of trials, P is the probability of success, and A is the number of successes. Now, if you ignore the left-hand side and think back to the tree diagrams, if I had probability of success and say I had 5 trials going on, so that's a 5-branch tree diagram, I had a number of ways of moving through the tree diagram, and that's what my N choose A is going to give me. Then I'd always end up with a set number of ways of getting the right probability and a set number of ways of getting not the right probability, the failure probability, and that's what 1 minus P is. And these powers had to add up to the total number of trials, which in this case they do. It also means that if I want to work out the mean of a binomial distribution, my mean is NP, my variance is NP and 1 multiplied by 1 minus P, and my standard deviation therefore is the square root of NP 1 minus P. Okay, now one thing that's happening at NCA level 3 is they do not use the letters A or P. For some reason they make A a little x, and I can kind of get that because that comes from an old bit of notation. I've chosen to change it to A, but they also have a habit of using pi, the Greek symbol for pi, for the probability, and I don't understand why they do that because pi is 3.14, but a probability has to be smaller than 1. It annoys me, but there's nothing I can do about it, so I'm just going to move on. But you need to be aware that that's how it's going to be written on the formula sheet, so you don't get confused by that. It's your responsibility to look at the NCA level 3 formula sheet and know what's there. So here's my distribution question. I will answer this actual question in the next video, but imagine I have many packs of cards. What the probability of getting a heart is 1/4. If I deal 6 cards, and then it's giving me a series of probabilities. And I need to ask, is this a binomial distribution? Well, if it was a pack of cards, then I'd argue it's not, because it fails on 2 of my conditions. There are 2 outcomes. There's either getting a heart or not getting a heart. There are a set number of trials. There are 6 cards dealt, so there are 6 trials. The question comes is, are the probabilities fixed and are they independent? And in a single pack of cards, you'd argue, no, they are not. However, in a multi-pack of cards, and I say I have many packs of cards, then you can assume they are independent, and you can assume the probability is fixed as 1/4. Okay, and that's a subtle difference. So that's something we're going to do about next time, but we do need to talk about our calculators, because you're actually not going to use those formulas most of the time. So if they ask you to work out an exact value, you're going to use on your calculator binomial PDF, and that is found under the distribution button. And where's my calculator? There it is, under the distribution button. So if I turn my calculator on, under distribution, so let's clear that. So I go clear, I go to the second function, distribution, and as I scroll up, I've got binomial PDF, and the order is number of trials, the probability, and the number of successes. Okay. If I want to work out something that's less than A does not include A. So I've got to work out the probability of X is less than or equal to a number. And that means I use a binomial CDF. And the binomial CDF is the next one down. So I've got to do number of trials, probability of success, and the amount is less than or equal to. If I want to do a greater than A does not include A. So I can go 1 minus, because it's the other half of the distribution. Probability of X is less than or equal to A. And if I want to do probability greater than or equal to A, I'm going to do 1 minus the probability is less than or equal to A. And all of those less than and greaters are